Back to another video, guys. It's all about A-level maths, and we continue topic related to circles. That's new syllabus for 2020 and onwards, and we gotta go to consider equations of a circle. Why I'm talking about equations but not one equation? Because there are several ways to perform equation of a circle. It might be contracted form when you have squares and expanding form. All right, so it's right time to know about this. And also, if you like dancing, don't forget to check my dance channel. You can find on YouTube by typing the words Daniel Dallas dance or how to dance. All right, and you find my channel. All right, let's get started. Alright, and you can see Pythagoras theorem. So you can see the circle with the radius of 4, it's centered in the origin. And what I'm going to do, I'm going to show you that the equation of the circle is the result of Pythagoras theorem. Alright, so let's take the random points. No matter where we take, we know that the position vector that starts from the origin to that point. So let's set a point, for example, somewhere here. We set up this point as P with the coordinates X and Y. And what I'm going to do right now, I'm going to say that, okay, we have a triangle, which is right angle. So from the origin, parallel to the x-axis and upward. So that's how we can set up the right angle triangle with a vertex P, O, and some another point, let's say A. So this triangle is right angle, and we can express the radius, which is in this case is 4. So but I use general notation R, and we can express this radius through two parts. So basically two parts are the legs, which represent the coordinates x and y of the point P. So what we can write that r squared is going to be x squared and y squared. Okay, so we can even check, for example, here we clearly know that x coordinate is 2. So for example, let's check. X is 2, radius is 4, and we can find out the y coordinates in order to reach point P. So let's set up this small question here in order to check what y is going to be about. So r squared is going to be 4 squared, which is 16, and that should be equal to x squared, which is 4, and also we need to raise y to the square, so that's going to be y squared. Okay, so y from here is going to be plus or minus 16 minus 4 is 12, so square root of 12. But we can even more simplify. We can say that it's going to be plus or minus 2 square root of 3. All right. So why we have two options for y? Because for given x, we have also another option for our point B to be with the same x coordinate equals 2. So here or here as actually we have. So for this reason, we take only plus, but make sure you remember that for a given x value, you will have two possible y values, and vice versa. For a given y value, you will have, for example, for this y value, we will have two possible x values as well. Alright, so that's how it works, and for this reason, we need to estimate that our y value is going to be about 3 something, right? Okay, so let's see. Let's estimate. Square root of 3 is around 1.7. So if we multiply by 2, we'll get 3.4. And we take the positive value. And this is exactly the same because my estimation is pretty nice and very close to true value. Alright. If you want to calculate precise value, you need to take calculator and do that. As you understand, so general equation for any point, no matter where we take, is going to be x squared plus y squared equals to r squared, where r is the radius of the circle. So this equation fair for the circle which is centered in the origin. So O is going to be the center of the circle and of the circle, and it should be in the origin. Should be in the origin. Okay. And we go next. And the next part here is general equation of the circle. What if you set up the circle and it's somewhere not centered in the origin? Let's set up P as a new point of the center with the coordinates, let's say x0 and y0. So we use the translation vector OP. So OP is a vector of translation, the vector of translation, so that we just moved our circle center O into new point P with the coordinates x0 and y0. So actually what happened, according to transformation theory, let's just consider a linear case, and for example we want to transfer our function f from x some units to the right. So let's say x0 units to the right. So how the general equation of a function will be changed in this case? Obviously, it's going to be x minus x0, and that's going to be the general equation of a new function. So in the same way, we can apply that to the y-axis. So just for y-axis, if we want to translate vertically, as you remember, you need to add or subtract like some c units, but outside the argument. Here it doesn't work in this case. So for y translation, you stick to the same rule and you just translate y in the same way as you translate x. So that means, y coordinates is going to be translated by the same shift, and you need to take into account minus y0 because of the nature of the vector, okay, of translation. And finally, if you have the original equation x squared plus y squared equals to r squared, and if you apply this way, you will get the following structure. You'll get x minus x0 squared plus the same for y and equals to r squared. And that's going to be the equation of the circle centered. So this is an equation of the circle with the center P with new coordinates x0 and y0. This is again because of the vector of translation. There you can see here it's OP, and that's, you just need to stick to the rule that you put argument inside the function. All right, so for y it becomes the same. Okay, so let's have consider a little problem about circles, and just pause the video, try first to do by your own, and let's see my explanations. Alright, so hope you did it, because it's based on all previous knowledge about bisector of the chord, and also equation of the line, so make sure you remember that. If not, just check out the video dedicated to how to cope with perpendicular bisector. It's all about that. Okay, and we start discussing. So we have a circle with diameter AB. So let's pretend that I just make a little sketch. So there are 2 points, A and point B, and what we're going to do, we just need to set up, in order to find the equation of the circle, we need to set up the center, let it be O, and that's going to be in midpoints. So midpoint. All right, so what we're going to do, we need to find the coordinates of midpoint O. So that's why we need to add corresponding coordinates and divide it by 2. We are taking arithmetic mean of corresponding coordinates A and B. Okay, so that's going to be 1 and 2, 3, and 3 over 2, 1.5. And what about y? 5 and 4, 9, 9 over 2, it's 4.5. That's the center. and we need to state the equation of the circle. But before doing that, we need to know the radius. So the radius is the half of the diameter, and we can find diameter as the distance between 2 points AB. So first, we're looking for the distance AB as the square root of taking the change in coordinates. I'll set up the formula first, okay? And instead of delta x and delta y, we taking change in coordinates. So 2 and 1 is going to be 1, and 5 and 4 difference is going to be also 1. So that means distance AB is going to be equal to square root of 2, okay? And because the radius is the half of the diameter, because AB now is the diameter, so we're taking the half of that. So square root of 2 out of 2, okay? So divided by 2. But we can simplify. Remember, square root of 2 and 2 can be cancelled. We can multiply both parts by square root of 2, and that means we will arrive to 1 square root of 2, okay? That's going to be the radius. And now we have point O as the center and the radius. So right now, I'll just rewrite those things here in 4.5. And with the radius, which is half of the diameter, 1 square root of 2. And we're able to set up the equation, okay? State the equation of the circle. We state the coordinates of the center in our equation. So, general formula one more time, x minus x0 squared, y minus y0 squared equals to r squared, where x0 and y0 are coordinates of the center. What we're going to do right now, we're going to just plug into the formula, and hence we can express the coordinates, the equation of the circle centered in x0 and y0. So r squared is going to be just simply 1 over 2 because we get rid of the square root. Okay, so now we can highlight that we've got the equation of the circle and we also got the center coordinates. Okay, next part, find the equation of the line that passed through the circle center. Okay, so we have, just strictly to say, we have this segment AB and we have a midpoint where our line goes through. So that's coordinates A and B, that's coordinates of the center, and this is the line, dashed line, represent the perpendicular bisector. Okay, it goes through the center of the circle. What we're going to do right now, we're going to express, set up first the gradient of AB. So the gradient of AB is just by definition change in y or change in x, and we just plug the coordinates of points A and B respectively. So 5 and 4 difference is 1, so we already fixed that difference. Is going to be just 1 over 1, and it's 1. So the gradient for the line which is perpendicular line is 1 over MAB due to the properties of perpendicular lines. So make sure you remember that. If not, just check out my video series dedicated to lines, to parallel, to perpendicular lines. You'll find it there. Okay, so now the general equation of the perpendicular line to AB is going to be minus, so the gradient is going to be minus 1. So minus x and plus unknown c value, which is y-intercept. How to find that? Because we know that this line goes through the center, and we know the coordinates of the center. We just need to plug the coordinates. 4.5 equals negative 1.5 plus c, from where we can express c value as 6. So final equation for the line which is perpendicular is going to be equal to y equals to negative x and plus 6. Okay, that's going to be a final equation of the line that goes perpendicular to AB. And we move to the last question. Find the vector of translation of the circle center has been translated to new point P and state the equation of the circle. Okay, so what I'm gonna do, I'm just going to come back to the center O with coordinates 1.5 and 4.5, and now we need to transfer using the vector of translation somewhere down, obviously, because coordinates are negative, to the point P with -2 and -3. So right now what we're going to say that OP is vector of translations, hence we need to find the coordinates of vector of translation as simply that's going to be set of coordinates changing x and changing y. So now we need to take change in x and change in y and calculate. So -2 and -1.5 is going to be -3.5. This is change in x, and the same for y coordinates, -3 and -4.5, -7.5. So because we've got the new coordinates, so we've got vector of translation, and we can find the equation or state the equation. So new center right now is point P. So finally we will get the following equation: x minus x0, so that becomes x0 and y0 coordinates in standard notation. So that means we'll get +2 because minus 2 squared, of course. And for y, we have the same y plus 3 squared. So what about the radius? Radius stayed the same, we just come back. We know that radius 1 square root of 2, but squared is going to be 1/2. So the right side is not changing because we don't have any transformation of enlargement, scaling up or down. So that's why radius stays the same. So on top of that, I'll give you extra bonus if you have any transformation related to changing the size of the circle so that it's rise up. So you just simply need to increase the radius corresponding to the scale factor. Okay, and that's going to be the solution for more complicated problems when you have like translation of the center of the circle, and probably the next transformation is just scaling up or down. Alright, so we've got the final equation of the circle centered in new point P, and that's it. So I think we've done everything except for two forms of the equation of the circle. When I'm talking about two forms, I'm talking about expanding form and contracted, and this is the right time to know about this. So what I'm gonna say right now, I'll be referring to the general form with x0 and y0 coordinates of the center. So that means the general form is going to be x minus x0 squared and y minus y0 squared equals to r squared. If we start, so this is their contracted form, so contracted form. And what I'm going to say that if we start expanding those brackets, we'll get the following structure. So I'll do it in a general way, but on the example, I'll show you how to do. So x squared minus 2x x0 plus x0 squared, and also with y's. So y squared minus 2y y0 squared plus y0 squared equals to r squared. So generally, what you can see that we have clearly x squared term, y squared term, and also linear terms of corresponding variables x and y. So that means because x0, y0, and r are numbers, so you'll have basically quadratic polynomial with x and y, like with sort of two variables. Okay, so that means I'll give you just example, and so this generally is expanded form. This is expanded form of the equation of the circle. And as you understand, because we can successfully expand those binomials, right? So we can come back to contracted form, and sometimes there might be questions about, please, from contracted form, you need to get the expanded form in the form like, sort of like x squared plus something x plus y squared plus something y, okay? And plus c, for example. And but the most common cases and the most common problems on the exams are from expanded form. You need to come back to contracted, to standard form of the equation. So this is why contracted form sometimes called standard form. Standard. Okay, how to do that? You just need to remember about completing the square, or you need to be able to complete the square, and that's the key factor. Or there is another way, using comparison methods. So make sure you know those topics. If not, just check out my GCSE stuff where you see completing square. You just search on my channel completing square, and also comparison method for coefficients, because like different students use different approaches. And we just go to the problem in order to understand how to do that. So we have we need to find the radius and the center of the circle with the equation x squared plus y squared minus 12x plus 16y equals 20. Okay, so if you want to just try to solve by your own, so try to do it, and it's going to be good practice for you guys. And I'm going to explain soon. So here we're going to start. I'll show you way one, so using completing square, and then I'll show you how to use comparison methods. Alright, so first, way one, complete the square. What we're going to do here, we're going to set up variables, first related to x, so x squared minus 12x, then goes y, okay, y squared plus 16y, and also you can transfer 20 here, okay, that's going to be 0. Now the next step is to remember about completing square. It's based on the formula a plus minus b squared, which is a squared plus minus 2ab and plus b squared. So it's based solely on that. What we're gonna do, we're going to take first part, which is here, and that's already x squared minus 2 times x and times 6. So you can just rewrite as 2 times 6x. So obviously the last term, which is b squared, is going to be 6 squared, because that's the only term, so that's the only number in between according to the formula. So that means we add right now 6 squared, which is 36, and we immediately take away that in order to keep our expression unchanged. Alright, and that's, as you can see here, this is already completed square because it fits to the formula. So next part related to y values. So right now we're gonna add y squared plus 16 is 2 times 8 y. So that means we're gonna use 2 times 8y, okay? And we need to add 8 squared, which is 64. We take away 64 immediately and minus 20 as well. Alright, and that's also completed square according to the formula. So finally we will get x minus 6, which is squared, plus, I've skipped this term and just continue with this according to standard equation, y plus 8, which is also squared. And finally, I just collect three terms, minus 36 minus 64 is minus 100 and minus 120. And I transfer it to the right side, 120 I can write as square root of 120, which is squared, because if you square the square root, you'll get just the number on the square root expression, so which is 120. So you know, this is the way how you can find the radius. So the radius obviously is square root of 120. If you like, you can simplify, like partly you can take square root of good numbers like a 4 or maybe even more. And you also need to find or state the coordinates of the center. So center coordinates O, as you remember, according to general form, is going to be x0 minus x0. So it's 6 and minus 8. So be careful about that. Keep in mind the right signs that you need to use in general form. Okay, so that was completing a square using first way. You just trying to use this formula. The way, actually, the second way that is based on comparison of coefficients works in a bit different way. So I'll just continue here, and that's gonna be the following. I just rewrite the equation. So x squared y squared minus 12x and plus 16y equals to 20. So what I'm gonna do right now, just lower the font type. Okay. What I'm gonna do, I'm just going to set up the general equation x minus x0 squared plus y minus y0 squared equals to r squared. What I'm gonna do right now, I'm going to expand that in general form. X squared minus 2x x0 plus x0 squared, and also here y squared minus 2y y0 plus y0 squared equals to r squared. Okay, so we've got this, and now what I'm gonna do, I'm just going to make comparison. I'm taking the first two terms, x squared minus 2x x0, and compare with x squared minus 12x. And obviously, what I'm going to notice that 2 times x0 is going to be 12, because this is the only coefficient before x. So, minus, so on top of that, I'm going to say that minus 2x x0 is going to be minus 12x. So, 2x0 is going to be 12, so x0 is going to be 6, and that's going to be the x coordinates of the center. In the same way, I will compare the next terms, y squared minus 2y 0y. With what? I'm going to compare with 16y, so that's the same as 16y. So obviously, negative 2y0 is going to be 16, okay? And that means y0 is going to be negative 8. Hence, I got the coordinates of the center as 6 and negative 8, and you can compare with the results that we've taken before. All right, so, but what about the radius? The radius is the rest part. So we can plug y0 and x0 into the expanded formula, and residually we will compare with r. So if you plug in, you'll have some numbers. So x0 squared, y0 squared numbers. If we just do that, we finally we can compare everything with 20. Okay, so let's do that. Let's just plug in here. Instead of x0 squared is 36. That's x0 squared. Next, y0 squared is negative 8 squared is 64. So add 64. And on the right side, that's going to be r squared. But if we transfer x0 squared and y0 squared to the right side, we'll get the following expression: r squared minus everything here is going to be the same as the free coefficient 20. We just compare now free coefficients. Okay, and it's going to be 20. And as you understand, this will add up to 100. And if you transfer to the right, we'll get r squared equals to 120. So if you're comfortable with this way, so make sure you can do that. This is way 2. or you can do using completing square as most students do. All right. So hope you like that, and that was all about circles, equations, different forms. I tried to combine everything in one video, so that is going to be from start point to the end point, and hope you like that. If you're new here, don't forget to subscribe, and also share the comments what you're going to see in the nearest future, because my goal is to finalize A level for nearest time, and just maybe to fill the gaps in GCSE, so that we have the complete manual with explanations and with practice for you guys. That was Daniel Dawes. See you next time.